Okay, so let's unlock two problems at 12, and we can wrap this up. Time dependent circuits. And I'll tell you, time dependent and AC circuits are really the most fun, practical part of this class. For I guess everyone, like if you are a physics major, you are likely going to need to deal with electronics, electrical circuits, as part of like laboratory instrument. And if you're an electrical engineer, then you know circuits are really important part of electrical engineering. And if you're neither, then you know this entire class doesn't really matter. I mean, it matters as a kind of underpinning of your understanding for example, chemical bonds. That it's electrostatic forces that form those bonds and all that. In any case, for the physics majors and electrical engineering majors, these two problem sets, 12 and 13, are really the most practical part. And this was actually my motivation for moving these topics up a little bit, because in the past these were coming at the very end of the semester, people didn't really have any time to put in. I swapped the order with the thermodynamics so that you would have sufficient time to look at these materials. So let me start with my usual prompt. I think it's this homework involving time dependent circuits. And then let's pick one or two substantive questions to work through with ChatGPT's help. And let me just, as a reminder, demonstrate one thing that ChatGPT won't be able to help you with. So, for example, if we were to give it this question and ask it, it says that these circuit elements are in series, and I'm having a difficult time visualizing it. Can you draw the picture for me? It won't draw the correct picture. It'll probably generate it using DALL-E, and when it does, it'll be some artistic drawing. It won't be correct. So in terms of drawing the correct figures, yeah, you still have to do it yourself. There's no way around it. This is so crazy. Microfarged. Yeah, that doesn't work. So let's do this. I think I can draw the circuit myself, and then ask it to help me with the analysis part. So circuit. The actually correct circuit would be the resistor, capacitor, and then battery. The direction of the battery I don't think matters for this question. So I'll say, alright, I got help with the circuit diagram. And I got the initial current by treating the capacitor like a short, something you might remember from when we covered chapter 10, but I'm not sure about the rest of the question. So let me, so this being short, the current should be voltage 9.5 divided by the resistance 300. So let me say that's 0.3 kilo ohm, because kilo will convert to milli when I do the division. So 95 divided by 3, 1.6, so 7, I think. 6 repeating. Yeah, I think that's right. Yeah, and I'll paste this in to show that I got A right. And it should give me the formula for RC time constant, literally resistance times capacitance. That's the RC time constant. It's like one of those situations where the name tells you the mathematical operation to do. So yeah, B should be easy. C, current through the after one time constant is. So there's a rule of thumb you could use, or you could do the full calculation. Let's see what ChatGPT suggests. Yeah, so this is the rule of thumb. Kind of, this is how much it, yeah, like dividing by E or dividing by about 3. And the voltage on the capacitor after one time constant is, yeah, it's giving me formula. So let's plug in the correct numbers for B and C, and I'll ask. I'm not sure where the formula for D comes from. So can I do this in my head? I might. 900 times 10 to the minus 6. So I think that's 0.9 millisecond. Current through the circuit after one time constant. So division by E to 1% precision is division by 2.7. Yeah, I don't think I can do that in my head. In any case, it's a waste of time, so let's just use the calculator. So 11.7. So I'll say great, I got B and C. Great. I got B and C. And just because I know the professor will ask at the oral exam, where does the formula for D come from? I mean, I will probably ask you, if you got this question. I'm asking you and you just cite me the formula. This is exactly what I would do. So comes from analyzing the charging process. Is a function of time. Yeah. Solving. Oh, okay. Yeah, if you can do this, then that's great. I might ask, where does this differential equation come from? But I think there I'll probably give you some help. It leads to that, in solving. Yeah. That's good. Now, another thing you can do is you can actually do it another way. So you got the current, which means you can calculate the voltage drop across the resistor. So that's going to be the current 0.0117 ampere times the resistance 300 ohm. So across the resistor, voltage of 3.51 drops. So subtract that from 9.5, get 5.99. That should be the voltage across the capacitor, because the Kirchhoff loop rule, once you complete the loop, you should come back to the same voltage. Rise 9.5, drop 3.51. So there should be a drop of 5.99 to come back to the voltage you started at. That's probably the way I would go. Like by default, especially given the part C, where you have to find the current already. So, all right, I think we got probably enough time for one more question. So let's do that. All right, I got it. The professor explained how to do this by using the answer to C. I wonder if ChatGPT will explain that process. Yeah. That's the exact reasoning I used. All right. Let's see. Let's do an inductor question. It's one of those things. Yeah, this is a tough question. So I believe. Let's see. Can I do it partially? Let's see. Let's see if I can do the easy part. So let's say you understand the steady state current circuit. with the inductors, you understand that steady state, it's like a wire. So wherever you see inductor, replace with a wire. Then you can see that I1 is just going to be the current through like this circuit. No current flows through R2. So it'll I1 will be the voltage divided by R1. I2 will be same as I1. So voltage divided by R1. And I3 is 0. And let's ask. So I'll say I got B, but I'm not sure how to do A or C. Okay. This is the next question. I got B by treating the inductor like a wire in the steady state current situation, but I'm not sure how to do A or C. Yay! Part A and C. Yeah. First close. So the rule should be this is like an open circuit. Any change in current. Open, and because it was having zero current before, so the moment the switch is closed, it's still zero current. So like an open circuit. Yeah, BS like an open circuit. Yeah, it had a zero before. The moment after, it's still zero. It takes time for current to ramp up. So open circuit only, it means R1 only. Therefore, oh, that's wrong. Yeah, why is it so wrong? So let's. I mean, so I got I2 right, but I1 and I3 will be wrong. So let's see if ChatGPT can correct itself. Imagining you are interacting, you put in the answers after thinking you understood this, but it's all wrong. For A, it looks like I2 was right, but I1 or I3 that. And you really should be thinking about it yourself. Then I think you get that if I1 is not 0, I2 is 0, then I3 actually cannot be 0. Because where else is this current going to go? So, alright, let's tell it wrong again. This time it's at least not internally, wrong logic wise. Well, let's just try it again. Nope. Is it not gonna get it? It's possible that it won't ever get it. Let me see if I do the other model, maybe it'll get it right. Let me nudge it a little bit. So if I remove the inductor, the circuit kinda looks like two resistors in series. Is that right? Once you realize this far, then you can answer it. Um, um, Yeah. So the second paragraph, the third paragraph is not right. Uh, no, this is the circuit. R1 and R2 are in series. So we'll take this. Uh, if the inductor branch isn't there. It's possible ChatGPT is true. I don't know. It's not quite spatial reasoning. I didn't think it would struggle with the circuit. Yeah, that is what it should have been. Understand why it took so long. Uh, and I think let's get an answer to C because C is actually quite interesting. So when the switch is opened, then now what holds so inductor is a quite open circuit. What holds constant is I2 continues to be this. So for a while anyway. So so let's scroll back up and see what it was saying for C. It was saying before for C, long time, steady state. Uh, yeah, these answers are right. So I think that's right. Yeah, it's kind of trippy, interesting in that there's no current through R1. This value it comes from this value, not from the Ohm's law, and it's like when the switch is opened, that dependence on R1. Wait, did I miss I3? There might be a minus sign. Yeah. It's a I think circuits are really it can be really interesting because there's a lot of complexity you can bring in. All right, and I got see. It looks like there's a minus sign for I3 though. Um, will it explain the minus sign? Makes sense because inductor maintain current, in opposite direction through R2. Yeah, yeah. So that's if you define the positive to be the direction it was flowing before, then yeah, it's negative. Yeah. All right, great. All right, thank you. And I'm out of time, so let's wrap it up here. Thank you so much for joining, especially for these three different problem sets. I'll see you next time.